For months, astronomers believed it was gone forever, a ghost from another star, lost in the dark between worlds. But last week, as a telescope in Hawaii swept across the night, a spark appeared where there should have been nothing, a glimmer that didn't belong to our solar system. When the data came through, silence filled the control room. The coordinates matched a name that had already become legend among skywatchers: 3I Atlas, the third interstellar object ever discovered. An outsider that once crossed our skies and then faded into mathematical memory. Except this time, something was different. Its light wasn't steady. It pulsed, alive, unstable, shimmering like frozen breath under sunlight. The models confirmed it. 3I Atlas wasn't an inert rock. It was releasing gas. It was forming a tail. It had come back. And it was a comet. No one could explain it. How does an object traveling from another star system return to the inner solar system? And how could its ices, formed under alien suns, still react to our light after such an impossible journey? Across the world, observatories locked onto its faint halo. And for the first time since its disappearance, humanity watched an interstellar traveler reveal its true nature. Not a fragment of debris, but a messenger. A body carrying chemical signatures that may have been born before our sun itself. And as its tail grew brighter each night, one question echoed through every radio telescope and observatory feed. What story is this ancient wanderer trying to tell us, now that it has returned? To understand why 3I Atlas's return is shaking the scientific world, we need to trace its path, not through imagination, but through raw celestial mechanics. When the object was first spotted in 2020 by the Asteroid Terrestrial Impact Last Alert System, ATLAS in Hawaii, it was moving too fast to be bound by the sun's gravity. Its velocity exceeded 30 kilometers per second, an unmistakable signature of something not native to our solar system. Like Oumuamua before it, 3I Atlas carried the momentum of another star. But its shape and brightness told a different story. It wasn't elongated or tumbling wildly. It seemed unstable, fragmenting, as if it had once been a comet that was falling apart. After a few short weeks, it vanished from sight. Most astronomers assumed it had disintegrated completely, a brief cosmic flare that would never be seen again. Its orbital data was archived, its mystery unresolved. Then came the new detections. In early 2025, a faint object was cataloged near the inner solar system, matching the old trajectory almost perfectly. The first suspicion was coincidence, until spectroscopic analysis came in. The spectrum contained telltale emission lines of cyanogen and diatomic carbon, molecular fingerprints of sublimating ice. Not rock, ice. That meant one thing. 3I Atlas had survived, at least in part. And now, exposed once more to the sun's heat, its alien ices were vaporizing, releasing a tail of dust and gas that could be studied. The reappearance immediately raised impossible questions. If its orbit was truly hyperbolic, how could it return? The best current models suggest something radical, that the original disintegration might have produced fragments, some expelled, some gravitationally deflected into temporary solar capture. This surviving core may have looped around the sun on a near parabolic path, taking years to re-emerge where it was first seen. But that's not the only surprise. Preliminary isotopic readings, particularly the ratios of deuterium to hydrogen, appear inconsistent with anything formed in our solar system. Its water is chemically different. That's not just poetic, it's diagnostic. It suggests 3I Atlas may have originated in a colder, denser region of another stellar nursery, where sunlight was weaker and molecular clouds older. What we're witnessing isn't just the return of an object. It's the first measurable evidence that interstellar comets can survive interstellar exile. And if this one endured a journey across the abyss and still responds to our star's light, what else might it be carrying within its frozen heart? Memory, molecules, maybe even the chemical seeds of alien worlds. For decades, astronomy treated the borders of our solar system as a kind of cosmic fence, a region that marked where we end and the rest of the galaxy begins. Anything beyond that invisible line was considered foreign, unreachable, beyond the scope of direct observation. But 3I Atlas shatters that illusion. Its reappearance doesn't just challenge orbital mechanics, it challenges our idea of cosmic isolation itself. Think about it. Every comet we've ever studied until the last decade was born under our sun's gravity. Their chemistry, their motion, their very dust particles told the story of one family, ours. And then, suddenly, In the span of just a few years, 3 visitors appeared from other systems: Oumuamua, 2I, Borisov, and now 3I Atlas. Not random fragments, but messengers from other suns, carrying the imprints of foreign creation. When astronomers confirmed that 3I Atlas was once again shedding gases, and that those gases didn't match any isotopic ratio familiar to our solar system, it forced a realization most people never considered. Space isn't divided by ownership. Matter doesn't respect borders. In a universe where stars drift and die and are born again, material from one solar system can be ejected, lost, and later absorbed into another, billions of years later. The dust in your bloodstream may once have belonged to a comet like this. The carbon in your bones may have been forged in a star that no longer exists. And yet, we speak of interstellar objects as if they were intruders, strangers, but maybe it's the other way around. Maybe we're the newcomers, living inside a gravitational eddy of borrowed matter that's been recycled countless times through alien suns. That's what 3I Atlas represents. Not an outsider, but a reminder that the universe never stopped mixing itself. When scientists tried to simulate its trajectory, the math defied expectation. The numbers implied that gravitational interactions with the giant planets, especially Jupiter, may have subtly altered its path, as though the solar system itself had reached out and pulled the traveler back for a second look. Coincidence? Maybe. But for some researchers, it feels almost poetic. The idea that our sun has a way of drawing fragments of the galaxy back toward its warmth, just long enough for us to witness them before they vanish again. The illusion of separation collapses here. There is no out there. There is only motion, endless, shared, and ancient. And if these cosmic wanderers can return, what else might already be on its way toward us, unseen, carrying another story from the stars? The first rung of evidence came quietly. A faint point of light in a set of images taken days apart by the Pan-STARRS telescope. At first, it seemed unremarkable, just another background speck. But when astronomers compared the images, the object had shifted in a way no ordinary asteroid would. Its path wasn't circular or elliptical. It was open, hyperbolic. It wasn't bound to the sun. That instantly narrowed the suspects to a handful of possibilities, one of them carrying an impossible name: 3I Atlas. The second rung came from motion. Its velocity, over 33 kilometers per second relative to the sun, placed it beyond any known comet from our own reservoir, the Oort cloud. The numbers match the archived trajectory of the original 3I Atlas within a margin of just 0.2 degrees, too close to ignore. It was as if the ghost of a vanished object had reappeared in the same corridor of space, years later, wearing a new disguise. Then came the third rung: light. Spectroscopy revealed emission bands characteristic of cyanogen, C2, and water vapor, chemical fingerprints of volatile materials sublimating under solar radiation. More than that, the intensity ratio between these lines suggested a nucleus that hadn't been depleted by prior passes around the sun. This wasn't a veteran comet from our system. It was a first-timer, still rich in primordial ices. Finally, the fourth rung: isotopes. Using data from the Nordic Optical Telescope and follow-up readings from ALMA, researchers detected a deuterium to hydrogen ratio nearly twice as high as any comet ever recorded within our solar system. That ratio acts like a molecular passport, proving the ices were born in colder, denser regions than the sun's birth cloud could have produced. Stacked together, these rungs don't just confirm identity, they form a bridge between stars. The object once labeled likely disintegrated now stands as a living sample of interstellar chemistry. But perhaps the most haunting detail lies in its variability. The comet's brightness doesn't follow normal thermal models. It pulses, brightens, and fades in patterns that imply either an uneven rotation or vents releasing gases in intermittent bursts, like exhalations from something ancient trying to wake itself up. Each observation has deepened, not closed, the mystery. Because if 3I Atlas really fragmented years ago, how could its surviving core retain so much frozen material? Enough to generate a visible tail again. Some astrophysicists are beginning to suspect the object's interior may be layered with exotic forms of ice, supervolatiles that remain frozen even at temperatures that would destroy typical comets. If that's true, then the comet isn't just surviving, it's remembering the conditions of another star system. And that realization changes the question from "what is it?" to something far stranger. How much of the galaxy's story is still locked inside that nucleus? waiting for us to read it before it vanishes again. What does it mean when something from another star finds its way back to us? The return of 3I Atlas isn't just a triumph of detection. It's a crack in the story we've told about where we come from. Because if this comet's ices were forged under a different sun, billions of years before our own, then we're not isolated products of one creation event. We're threads in a far older tapestry, one the universe has been weaving since before there were names for light or time. In laboratories studying its spectra, scientists realized they weren't just measuring chemistry, they were touching memory. Each molecule of frozen water, each grain of dust, carries the imprint of another environment, a fingerprint of a place we'll never visit, but that still exists inside this traveler. The comet is not a stranger then, but a messenger, or perhaps a mirror. For centuries, we've imagined cosmic discovery as expansion, the act of reaching outward. But 3I Atlas reverses that direction. It comes to us. It brings the unknown closer. It's as if the universe itself decided to remind us that exploration is not only about movement through space, it's about deepening awareness within it. Skeptics, of course, remain cautious. They argue that philosophy has no place in data, that this comet is nothing more than a piece of frozen debris obeying gravity and sunlight. And yet, even those skeptics quietly watch the same live feeds, the same halo of vapor surrounding a nucleus born under another sky. Because even when you strip the poetry away, one fact remains undeniable. We are observing alien material, truly alien, reacting to our star. It's as if two histories have touched for a brief instant, one written around another sun, one written here. This moment invites a shift in how we see not only astronomy, but existence itself. Perhaps the universe is not a collection of separate systems, but one continuous process. Matter, migrating, evolving, remembering. Perhaps what we call origin is just one of many local versions of the same universal story. 3I Atlas reminds us that nothing is truly lost, that even across the distances between stars, fragments can endure, return, and reveal. And if a piece of ice from another world can find its way back to the warmth of a familiar sun, what does that say about the nature of connection? About the possibility that the cosmos itself has a kind of memory, and that we are part of it, remembering itself. If the story of 3I Atlas ended here, it would already be historic. The first known case of an interstellar object reappearing and revealing itself as a living comet. But what comes next could redefine how we explore the universe itself. Right now, observatories across the planet, from Mauna Kea to La Silla, from ALMA to the James Webb Space Telescope, are converging on a single goal: to capture every possible photon reflected from this alien nucleus. JWST's near-infrared spectrometer has already scheduled emergency observation windows to analyze the comet's volatile compounds. The hope? To detect complex organic molecules, the kinds of carbon chains and nitriles that, on Earth, are the raw ingredients of life. If such compounds appear in the spectra, the implications will be staggering. It would mean that the chemistry of life is not unique to our solar system, that it naturally emerges in multiple environments across the galaxy. And if 3I Atlas truly carries organic molecules from another stellar nursery, then those molecules are already mingling with our solar wind, our dust, our light. In a sense, interstellar exchange has already begun. The discovery has sparked renewed discussions of sample intercept missions, spacecraft designed to rendezvous with fast-moving interstellar objects. A new generation of designs, inspired by Breakthrough Starshot and NASA's interstellar probe concepts, are being revisited. Lightweight probes propelled by solar sails or ion drives could theoretically catch up to an object like 3I Atlas on its outbound trajectory. The idea isn't science fiction anymore. It's becoming engineering. There's also a growing philosophical movement within astronomy circles, the Cosmic Heritage Initiative, a framework proposing that every interstellar object be treated not as a target, but as a relic, a form of cosmic archaeology. Because if these bodies are truly fragments of other suns, then each one is a record of a chemical and physical story that no longer exists anywhere else. And beyond science, something subtler is happening. The public reaction, the fascination, the collective awe, shows that we're beginning to see our solar system not as a walled garden, but as one node in a galactic ecosystem. Soon the word interstellar may stop meaning distant. It may come to mean shared. The next generation of telescopes, missions, and minds will chase that truth. They'll search the sky not just for what's out there, but for what's returning. And if 3I Atlas truly survived the long cold between stars, maybe it's not the only one. Maybe dozens of other fragments are drifting toward us right now. Silent emissaries carrying whispers from other suns, waiting for us to notice. Some nights, when the sky is clear and quiet, you can almost imagine it. A small, cold body drifting across the dark, trailing a faint thread of vapor that will never be seen by the naked eye. Somewhere out there, 3I Atlas continues its slow glacial journey, carrying the chemistry of another sun through the light of ours. And somehow, knowing that changes the way we look at everything. For centuries, humanity has lifted its eyes to the sky, not just to measure, but to remember. We've named constellations after gods, mapped our myths among the stars, searched for patterns that might remind us we belong to something larger. The return of 3I Atlas does more than feed curiosity. It reawakens that ancient instinct. It's a reminder that we are participants in the same cosmic rhythm, not spectators. There's something almost personal about it, as if the universe sent back a piece of its own past just so we could see what endurance looks like. A body that crossed the cold between stars, shattered, and yet reappeared glowing, alive again. How could that not feel familiar? We, too, are fragments that endured the void. Every atom in our bodies once traveled the same interstellar pathways, forged in collapsing stars, scattered, and gathered again into this fleeting form we call human. When we watch 3I Atlas come back to life under sunlight, we're watching the same process that shaped us. The same physics, the same persistence, the same cosmic memory. Maybe that's why this discovery hits so deeply. It's not about another comet. It's about continuity. The realization that nothing, not even distance between stars, can erase connection. And yet, there's another layer. Wonder mixed with responsibility. For every observation we make, we leave a digital footprint. Data that future generations will read the way we read starlight. Our telescopes don't just collect light, they collect meaning. They record how we saw the universe at this moment in time, how we tried to understand it. Perhaps one day, someone on another world will look up and trace a faint streak across their sky, one that came from here. And maybe they'll feel what we feel now, awe, recognition, and the quiet certainty that across the vastness, the universe is still whispering to itself through us. Because if a fragment from another sun can find its way back home to light, maybe we can too. The last time 3I Atlas was seen, it faded into the dark, a brief flash from another world, swallowed by distance. Now it glows again, not as an intruder, but as a survivor. And in its return, it's as if the cosmos itself offered us a quiet message, that nothing truly disappears. It only transforms, waits, and finds another path home. The data pouring in from JWST and ground-based telescopes will take months, maybe years, to fully decode. But long after the light curve flattens and the comet fades beyond detection, something deeper will remain. The knowledge that we have witnessed an echo of another sun. That's what science really is. Not just the act of discovering, but of listening. Of noticing the universe speaking in small, fragile signals. The shimmer of a tail. The spectrum of alien ice. The persistence of something that refuses to be forgotten. And maybe that's the real story of 3I Atlas. Not that it came back, but that we were still here to see it. Still curious enough to look up. Still patient enough to listen. Still capable of awe. Because the universe is not silent. It just waits for minds willing to understand its language, and hearts willing to be changed by it. So tonight, if you look at the sky and remember that somewhere out there drifts a comet older than our own sun, ask yourself this. Do you believe that 3I Atlas found its way back to remind us how connected we truly are? Or is the universe still trying to teach us a pattern we haven't yet learned to see? Tell me below.